One of the first things we have to do before we start doing the classical NMR is to understand what strength magnetic field we're going to be able to immerse our samples in. And where the magnetic field comes from are these big coils you see here and here forming an electromagnet. You can see the magnetic field is sort of routed from these coils up through these big thick pieces of metal right here, probably iron metal. And the sample goes in this hole here right in the center, so the magnetic field sort of is in this gap where you see this brass piece here. So what we have to do then is get a correspondence between current, which will be supplied by this somewhat out of focus power supply over here, but it's okay. I'll tell you why in a minute. The current that's going to be supplied by this power supply and the magnetic field that we actually get in this gap here. So we have to have some correspondence between that, so we'll always know for a given current setting of the NMR what magnetic field is our sample sitting in. The way we'll calibrate that for the current anyway is just to use an ammeter right here. I have this ammeter wired in series with the electromagnet coils and the power supply over here, so you can see as I just start turning the voltage up, you can see the current starts to rise. And so that's why it's okay to keep the power supply over here in the background, sort of out of focus, because all we're really worried about is what current is delivering to the coils, and we can clearly see that on this yellow meter right here. Okay, the way we'll get about the magnetic field here is to use this DC Gauss meter. So it has a nice probe on it that basically tells us the strength of the magnetic field passing perpendicularly through this flat area here. And so you see as I sort of wave it around, it definitely is having some response on the Gauss meter right there. Again, the numbers are in Gauss, so it's magnetic field in Gauss. So right now it's reading 61.2 Gauss. The best uses of the probe is when the magnetic field is always perpendicular to this flat surface here. So what we'll do is just sort of put the probe inside this hole here on the top, which is going to be where our sample will go, and we're interested in the magnetic field. And we'll rotate it around a bit until we sort of maximize the field. Oh no, maybe something like maybe there or something. And I don't have any current going through the meter at the moment. So this should sort of be our zero in magnetic field, but I think I'll just leave it because it's kind of small. I mean, I could press this auto zero button right now, but I think I'm just going to leave it because it looks like there is hardly any residual field in there or anything. And so we'll just begin then. And so what I'll do slowly is I'm just going to start turning up the voltage on the power supply. You'll see current flowing through here, and I will tweak the orientation of this probe just a little bit to maximize the magnetic field, but hopefully you can generate for yourself magnetic field versus current pairs here as we go. So why don't we just start up with our first data point here or so. There's about 0.38 amps. I'll just rotate this around sort of to maximize the field. I'll say it's probably about there is where I'm going to leave it for the duration. I don't think I need to keep rotating it. So there's a data point for you right there. And I won't talk very much anymore. I'll just let you take your current versus magnetic field data points. And we're up to about 7.5 amps now. That really isn't going to be necessary for the experiment. So maybe I'll just back off a little bit more, see if we can just generate a few more. Okay, and I guess we'll leave it about that. So I'm hoping that all the numbers that you saw flash in front of you just now, that you should be able to come up with a good correspondence between magnetic field produced in the electromagnet and the current that's supplied.